Welcome. So today we will review everything there is to know basically about acids and bases. So the first things we need to understand about acids and bases is what they are. So there's 4 different types of definitions of acids and bases that we will get into. First one is the sensation perception definition. So sensation perception is basically what you feel, what you taste, what you smell, anything of that sort. So for acids, commonly anything that has been described to taste very sour has been defined to be an acid throughout history. For bases, it has been anything that is extremely slippery or anything that tastes very bitter. So a common example of an acid is something like vinegar. And a common example of a base is something like soap. So soap is slippery, and if it's ever gotten into your mouth while you're showering, you know it's bitter. So the previous definition, the sensation perception definition, this is very qualitative. It will not be used at all when taking into account calculations and different reactions. So next is the Arrhenius definition. And the Arrhenius definition has to do with the ions formed in aqueous solution. So acids will always contain H plus in their formula. So for example, you have HF, HBr, HI, HCl. All of these have the H plus at the front end of the compound. So we know that these are all acids because they have that H plus. And acids will form the H3O plus ion in solution. So that is the hydronium ion. Now bases will always have OH minus in their reaction. So you can have LiOH, you can have KOH, you can have NaOH, which is sodium hydroxide. You can have all of those. And we know these are all bases because at the right side of their compound, they all have that OH group, otherwise known as the hydroxyl group. And bases will form OH in solution as well. Next we have the Bronsted-Lowry definition, and this has to do with protons, which is H+. So acids will always donate protons, and bases will always accept protons. Next we have Lewis structures. Now, we know from Lewis structures in the past that it's all about trying to fill your octet rule and lone pairs, blah blah, all that stuff. We know it always has to do with electrons. So the Lewis definition will always have to do with electrons. So if you remember from Bronsted-Lowry, which we just talked about, acids will donate protons. So if they're donating protons, that means they're losing that positive charge, they're losing that H+. So they will be accepting electrons because they will be accepting that negative charge. And bases, the opposite is true. Bases are going to be the ones donating the negative charge, which is the electron.